Hello and welcome to another video. This is going to deal with the proportion of population, and here is the problem, and we're going to walk you through this. Also, I'm going to be sending you multiple problems in order to relate to it, so we could do it together. The national, the NFL believe the chance of Patriot winning the coin toss is greater than 150. So there is a belief that there is a proportion of 50% for the population, but the statement here indicate that there is an alternative hypothesis that is going to be greater than the 50%. Anyway, in a random sample of 200 coin tosses, the Patriots won 118. If there is enough evidence to suggest the Patriots are cheaters, are they using a coin somehow and deceiving how they throw it up the air and getting really advantage of it? So the proportion is going to be using the z-score in one way. If we have the number of the proportion for the population, which is in this case is 0.5 multiplied by n, which is 200, it's going to be greater than 5. Also, if the q, which is 1 minus p, which is in this case also 0.5, multiplied by the 200, it's going to be greater 5. So we could feel completely confident that both of these values are greater than 5, so we'll go toward the direction of using the z calculation, the z-score to calculate the proportion. So what I'm going to do is go ahead and walk you through this in Word. And as you notice here, I stated the null hypothesis and alternative. P is equal to 0.05, and the alternative hypothesis is P greater than it stated that clearly in the question 0.5. Since we have the 95%, no other confidence value included, so we're going to grab the 95%, resulting into an alpha of 0.05. And here another test to determine the z-score, whether we can do the z-score or not, is to take the p, which is the 2.5, multiplied by the n, which is the 200, resulting to 100 greater than 5, and the q n, which is 1 minus p, which is 0.5, multiplied by n, which is 200, it's going to be 0.5 multiplied by 200, resulting to 100 greater than 5. Therefore, we're going to use the z-value. But what is the z-value at the confidence interval with one tail at 95% or at alpha 0.05? That's very easily obtainable through the Minitab or through the end of your book or through Google's, with which we could test that, or look at the sheet that I handed you in the class. So I'm going to go to the graph and I'm going to go to the probability distribution. Still, look, we are doing the proportion, but we're looking for the z-score because we proved that the sample big enough to use that sample, to use the z-score. And here we go. We have to use the normal. If it's not there, you have to change it. We're going to leave the mean at zeros and the standard deviation at 1, and we're going to go to the standard area. It's going to be the right tail at that probability of 0.05 for alpha. So I'm going to go ahead and click OK. And notice we're going to get that critical value start at 1.645. Again, this is a positive value, as you notice, so I'm going to go ahead and put that here. Z is 1.5. So we're going to be calculating actually Z based on the proportion, which is a different formula. So I'm going to switch you here to Excel to see the actual formula, since I don't have really an editor with a pencil or to write over it. So the Z for the proportion is the p hat minus p divided by the square root of p multiplied by the q divided by n. P hat is going to be the 118, the observed number of tosses, divided by the total, which is the n, and it's going to give me 0.59. And p, as stated in the null hypothesis, is 0.5. So also under the denominator, which is going to be the square root, as you notice, square root of what? It's the 0.05 for the p, multiplied by the q, which is 1 minus the p, which is also 0.5, okay, multiplied by, or divided, sorry, by the 200, which is in this case is the number of items or number of tosses in basically. And so we're going to go ahead and do this. Go back to the formula. It's going to be b hat, which is this b hat, open parentheses, b hat minus this guy here. We need to do that rule of order divided by the result value from the square root. Please take a moment here so I don't get confused. I get confused with it. So I try to read slowly through it so I could get it. And as a result, as you notice, we got 2.5455. I could go ahead and make it only 2-digit to the right of the decimal points. This is into, I'm going to go ahead and do it this way here. It's going to give me 2.55 digit, approximate, rounded to 2-digit of the right of the decimal points. And I'm going to go back to my C. Is 2.55 greater than 1.65, which is 4, sorry, which is a true. So we reject the null hypothesis. We reject the null hypothesis. What does that mean? It means that these patriots, actually the patriots, are cheaters. They're actually doing that cheating for, as it stated in the last part of the problem. And it says here, there is evidence to suggest the patriots are a cheater because we rejected the null hypothesis. They believe the chance of patriots winning the coin toss is 50%. No, we come up with a rejection value. I'm going to go ahead and do that with the also the mini tab to speed up the process because we want to make it both ways. If we get the p-value less than 0.05 and also if we got the value greater than 1.645, we could reject the null hypothesis as well. So what I'm going to do here, I'm going to close this, and this is going to go to the stat, and I'm going to go to the basic stat, but now we're going to do one proportion. I don't have the data scattered all over the places, so I have a summarized data, as you notice, summarized data. There we go. And now it's telling me what is the number of the events versus what is the number of the trial. The number of the events is 118, and the number of the trial is 200. That's the total. And we're going to perform a hypothesis test. Hypothesis proportion is 0.5. That's what is the null hypothesis. And we're going to go to options and make sure that we're doing it on the confidence level of 95. You could always change that to higher or lower since it's going to be greater. So it's going to be the proportion is greater than the hypothesis proportion. And we're going to leave it as exact. That's the default one. We're going to say OK. And we're going to run it that test. Notice we're going to get the b value, only the b value in this case, which is going to be 0.007, which a lot smaller than the 0.05, which is the alpha value, and therefore we're going to reject the null hypothesis. Again, the higher we go with our statistical knowledge, we're going to be depending on the b value more than anything else. Okay, as you notice here, n is 200, the event are 118, and sample is, the sample p. Those are not really critical at this moment. We did make it sure that's 95%, but it only gave me that b value when I run the test. I don't know if I could do something else beside this. Let me go ahead and do this with that stat, basic stat, and run proportion. And let me see the option. There is no other option it's giving beside this. So we have to really rely on the p-value in this case. And it didn't show me the z value that's we calculated manually through the formula of p hat minus b divided by the square root of pq divided by n. Thank you for watching, and we have one more video that is going to be concerned with the chi-square, which is much easier to do. Thank you.